We're going to take a look at this optimization problem, which is what is the minimum vertical distance between the parabolas y equals x squared plus 1 and y equals x minus x squared. Now, whenever I am looking at what happens with a couple of graphs, I kind of want to graph them. So I am going to run over and look at what the graph looks like. And here I've graphed it on Desmos. Here is, what were they? Y equals x squared plus 1 and y equals x minus x squared. You can see them over here. Of course, y equals x squared plus 1 is the one that opens up, and the one with negative leading coefficient is the one that opens down. And what we're looking at, it asks, what is the minimum vertical distance? So between any 2 points, there's at any given x value, there's sort of a vertical distance between these points. So I actually put these up. So this would be the vertical distance between the 2 graphs at various x values. Okay. And you can kind of see, it looks like maybe the minimum distance might be, I don't know, somewhere around here-ish. I can't tell what this is, about a quarter or so. So we'll see. We'll do the algebra to figure it out, the calculus. But it's good to sort of see what picture we're looking at first. So going back here, I did actually copy this into my paper here. And when I'm looking at the vertical distance, I'm just going to sort of keep track of what we're looking at. So at any given x value, I can sort of look at this, and that is my distance d. Okay, so now when I'm calculating this, the distance between 2 y values, it's the difference between the y values for any given x value. So the d is going to be the difference in the y values. The one that's on top, the greater y value, is x squared plus 1. And then minus x minus x squared. So I should point out distance is a function of x. Okay? And so let me just simplify this a little bit. D of x equals, let's see, it's x squared plus 1 minus x plus x squared. So it's 2x squared minus x plus 1. Now, in order to minimize the distance, it's good that I have, so this is a quadratic function, and its graph will be a parabola that opens up, which does mean that it has a minimum value, not a maximum value. That's good because we are searching out a minimum value. All right. So in order to find the minimum value, I'm going to take the derivative. And that is going to be 4x minus 1. And I want to find where the derivative equals 0. So that is where 4x minus 1 equals 0. And that is where x equals 1/4. And that is very close to what we saw in the graph just by dragging that distance around. So that means that my minimum distance is here at x equals 1/4.